Hey folks, welcome back. This is Joel, and in this series, we are talking about Aruba's Silver Peak SD-WAN solution. And in this video, we'll talk about business intent overlays. Now, you can actually go and check out the previous videos of particular series on my channel, right? You'll find them probably bundled in a particular playlist by the time I publish them. But that being said, let's come back. Today's topic is business intent overlays, right? Now, we've done a double click on this at the start of the series, right, in the introduction, but just to kind of give you a glimpse. In any SD-WAN, you're going to have an underlay, right? And the underlay is generally what? So in this case, this is an appliance, right? So you are going to have the WAN here, WAN side. So your underlay is nothing but your 4G or internet or MPLS, the various type of transports, right? The physical links and the IP addresses on those links, all of that constitute the underlay, right? How this particular appliance connects to the transport, right? What is the IP addressing? Is it using static routes? Is it using BGP? All of that is your underlay part. Second thing is your overlay. Overlay is generally your IPsec tunnels, right? So most of the time, most of the appliances or most of the vendors prefer to do IPsec because for security purpose. So you will technically have something like this, right? So you have two appliances here. You can technically have like a IPsec tunnel going from one appliance to the other, right? So that's your, I'll just put an example. IPsec is your overlay. Okay. Now the third thing, right, which is again not very common, but Silver Peak you will find this, right, is called as business intent overlay. Just when you look at the word, right, it can be a mouthful, but it's not something which is very complicated, right? I would say I think the people who designed it probably named it a little inaccurately, because business intent overlay is not some new type of overlay. It's just think of it as a profile, right? It's just a profile for what? For different type of applications and how you want your SD-WAN to handle those applications, right? Let me give an example. So something like this. So you can have technically, right? So technically you can have different type of traffic, right? You can have real time. You can have bulk apps, correct? You can have critical apps, right? Now you will have all of these different types of apps. How do you want these, once if your appliance is able to, kind of classify a particular traffic as real time. Real time is what? Voice and video, right? Bulk is what? FTP, TFTP. Critical is, maybe something very critical for your business, Office 365. And this list is not exhaustive. You can add more, right? But profile or business intent overlay, what it does is it basically gives you a way to handle your traffic based on the category. It tells you, okay, for real time, which tunnels should I use? Should I use tunnels via the 4G, or should I use the tunnels over the internet, or should I use MPLS, right? How do I handle traffic between two Edge Connect appliances? How do I handle traffic which is going from the Edge Connect appliance to the internet for the real-time traffic? So all those settings per application is defined, right, in a central place, and that's your business intent overlay. It is not an overlay by itself. It's just a way to define those settings, and ultimately the traffic will be sent on this overlay itself, this IPsec tunnels, right, which will again ride on this underlay. So that's all. Whatever you have learned about SD-WAN right till now with the other vendors and everything is still intact. It's just that these guys have a way or a settings, right, of sort where you can define how the applications are handled. So that's your business intent overlay. Okay, so let's clear this up. All right, so now coming to, if you come down to my orchestrator, right, you will find this. A few things here, right, I want to clarify before we head to the actual lab is, let's just try to understand this a little bit more, right? So if you see here, we've got, this is where you define your business intent overlays, right? And you can see on the left hand side, you've got the priority. You've got priority 1, 2, 3, and 4, right? And you can see there are different overlays for different type of applications. And you can see for each of the overlay, on if you horizontally look at it, right, you have a lot of settings. What type of interfaces to be used, what type of topology to be followed, right? The QoS settings, the security settings, right? And all of that. The other important thing is you see that you'll always have two boxes. One is this one and one is this one. So this box basically means that these settings are related to how the traffic has to be handled between two edge connect appliances, right? Which means, say you have an appliance here, you have an appliance. This is in Mumbai, this is in, I don't know, Canada, right? And you have some LAN behind this. This might be the 10 network, right? And this might be, I don't know, maybe behind this you have the 172.16 network, right? Different LANs, right? Now, ideally what you're going to have your IPsec tunnels or some, yeah, you'll have IPsec tunnels over internet, MPLS, whatever, right? Now, if these two guys have to talk to each other, they have to do it over these tunnels, correct? So that is addressed in this particular section, right? Now, the same use case, the other use case could be this guy who is sitting here in this LAN might want to also access what? Internet, maybe 8.8.8. So that traffic will have to be directly sent on the internet, leaked on the internet transport, right? So that is handled in this section. So that's the difference between them. So you see right from the title also, this says SD-WAN traffic to internal subnets, which is traffic between the two appliances. So internal subnets, you see this subnet and this subnet. Whereas this guy handles traffic to the internet and cloud services. So the settings are kind of divided, categorized it in that manner, right? Just for ease of access, right? Now, just for understanding purpose, let's actually open this, maybe open it up and just have a look, right? So if I open up one of these guys, click on this, you can see various types of settings, right? So right on the top, you can see the type of traffic. See on the top, you can see the type of traffic which is matching. You can see the topology on the left hand side, which is going to be used. These are like the various type of settings around what interfaces you want to use, right? Which one you want to use as primary, which one as backup, right? And then on the right hand side, you have service level objectives. So if these objectives are not met, you can say loss of 2% is allowed. Latency of 50 milliseconds is allowed, right? So you can define that, and those are not met, then that particular interface will be removed from this particular service, right? The interface will still be operational, but it will be just removed from this particular service for forwarding for this particular traffic, right? And then a backup interface can be used in case, right? If you don't have enough interfaces to service that particular overlay, right? Below you see you also have various settings, right? You can actually change settings like if you want high availability. Sometimes for certain traffic you want high availability, right? You want to make sure that you're not very concerned about the quality. All you're concerned about is more availability, like you don't want the link to go down. Then you can use these settings. If you want high quality, maybe for real-time traffic, right, you can use this setting. So again, internally what it does is it will enable certain other settings, right, like forward error correction. It will enable path conditioning, right? It will do all that boost related TCP acceleration. All of that related settings are actually enabled in the background. All you have to do is come and select what kind of a bonding policy you want here based on your traffic, right? So that's the cool thing about Silver Peak, right? So all of these, if you had to really sit and do it via CLI on a traditional router, you will take ages. But here you see, you just with a click of a button, what you're able to do is you can address a particular type of traffic, and you can also enable certain best practices or best features which will really complement that particular traffic, by just go and selecting here. Okay. So yeah, this is basically, like I said, these settings are only for traffic between two subnets, internal subnets. Whereas similar settings you are available, here on the, you also have settings for traffic to the internet. And what do you define as traffic to the internet? You can click on this pencil icon here, and you will see here it says, see, you can basically add here, but these are the subnets which are considered as internal subnets, right? So which means any traffic destined to this internal subnet will go to this first option, right? If that destination IP is not part of that internal subnet, it will use these settings. That's the meaning of it, right? So yeah, that's the main concept of business intent overlay. Now, maybe one more thing we can cover here is what really happens when the traffic really comes in, right? So let's try to kind of understand that. So first thing what happens is, if I have, say, as the traffic comes into a box, right, a Silver Peak box, first thing we're going to do is we're going to check match, right, which bio it is going to match. You see there is a priority here. So we're going to check, is it going to match here? So we're going to check, is it real time? Is it critical apps? Is it bulk apps? So that matching is done, right? Once you are once you're done with the matching, next what happens, that traffic once you have decided that it is part of real time, right, now these settings will have to be used, right? So first thing, the next very thing, SD-WAN tries to do is it tries to understand if I have to use this or this, and that I can do using the subnets, correct? I just now showed you a list of subnets. So if the destination IP, no, before that actually, I mean, the other important thing is also checking if there is a, for that particular overlay, is there a breakout even configured, right? Sometimes this might not even be there, right? So checking for is there a local local breakout configure, that's important, right? So here that you check. Third thing would be, okay, if the breakout is configured, now you need to kind of differentiate, do I need to use these settings, right, or these settings? So for that I will be able to do that using what, internal subnets, correct? I just now showed you the internal subnets. All I have to do is look at the destination IP address and see if it is matching the internal subnet. If it is matching the destination internal subnet, what I will have to do, I will have to come to these settings, right? Now once you come here, all I have to do is I have analyzed that it is that particular IP address is part of an internal subnet. Then you will have to just check the routing table, right, on the appliance to check if the destination IP is part of the routing table, right? So the routing table will clearly tell you which overlay to use, right? Because between two appliances there might be multiple overlays, correct? And we also see here, right, you can define which interfaces which transports you really want to give priority. So based on all these settings, right, what will happen is finally traffic will be sent on those IPsec tunnels towards the destination edge connect appliance, ultimately to the actual destination. Now what if while you are here you realize that the traffic is not destined to the internal subnet, it is destined to something like 8.8.8, right? Then what will you do? Then basically we are going to use these settings, not this one, whereas you're going to use the settings on the right? And based on the settings on that, the traffic will be sent to directly on the WAN interface, because like I said, this is basically traffic destined to the internet, right? So either it can be local breakout, which is you directly send it to the internet from your own appliance, or there is an option to backhaul as well. Backhauling is nothing but you can backhaul to a hub of sort, right? So you can create one particular appliance as your hub, and you can send the traffic to that hub, like maybe it's like a headquarters where you might have some kind of firewall, right? So you can send the traffic to that, and from that appliance's local breakout, traffic will exit, right? So that you have two options, right? This is a very traditional way, whereas breakout is a local breakout. If you are using local breakout, technically what people also do is they use Zscaler and such kind of SSE providers, right, to kind of make sure that their traffic is getting inspected, right? So you have all those features as well. I'll not get too deeper into that now, but this is a general flow of what happens when the traffic comes into the box, how the matching is done, right? Are we going to use policies on the right or policies on the left, right? And if you are using policies on the left, we check the routing table, then everything is good. We decide which tunnels we have to use, and based on the settings as well here, we are going to finally send it on the IPsec tunnels. If the traffic is destined to the internet, we obviously have to use the policies on the right here, right? And either you can do locally breakout, or you can send the traffic, again using the IPsec tunnels, but send it to the remote, maybe a edge connect appliance which is in the headquarters, right? Send it over there, and once that guy receives the traffic, he might send it to a firewall, right? And from there you can send it to the internet, right? So that's the whole flow, and you'll probably understand more of this as we get into the lab part, but that's the overall idea of what we'll be doing in this particular video. We'll basically try to explore these various BIOS, try to configure them, explore them, send some traffic, and see what's really happening behind the scene. Okay. All right, so let's start by modifying some of the BIOS here, right? So we're looking at the real-time BIO here, so let's click on that guy. And you can see if you look at this section, right, there are a lot of things happening here, but let's probably look at this section over here to begin with, right? Available interfaces. You can technically just drag and drop this way, right? You can add the interfaces from the available section to your primary or backup. In our case, as you see, we don't have, in our topology, if you remember, we don't have more than one MPLS. So I'm gonna put it back here because we we don't really have more than one MPLS or more than one internet, right? So these, as you see here, these are iNet 2 and MPLS 2 interfaces. What else? So you can also see on the right hand side, right, you have service level objective. So this basically is, think of it as what we did with that application aware routing, right, in Cisco's Viptel as well. You can define, like for example, I can say a loss of 2%, a latency of say 100 milliseconds, right, a jitter of 0. So I can define some service level objectives this way, right, and I can say that, you know, if these service level objectives are not met, right, then you can you know, change the interface, right, which will be used for, or you can change the transport which will be used for sending the data. I mean, the transport will not be directly used. Obviously, there will be IPsec tunnels on these transports, but the understanding is that you know, IPsec is just a logical tunnel, right? And what is really going to influence these three parameters, loss, latency, jitter, is the actual physical transport. So this particular setting basically makes sure that you know, if these service level objectives are not met, you know, the appliance can use the interfaces mentioned here in this order, right? Either MPLS, if MPLS doesn't give you enough SLO, then use iNet, right? If these both are not available, then kind of use the backup interface, correct? There are other few options here as well. As you see here, you know, there's another interesting option. Let me see if my pen is working, one sec. Right, so there's another interesting option, which is, as you see here, something called as peer unavailable, right? And what does that actually mean is, let me use the topology, one sec. Right, so what does that peer unavailable option actually means is, so say for example, you've got one appliance here and the other appliance here, and you have some kind of transport, right? Maybe a MPLS or internet, whatever. You have IPsec tunnels between these guys, like this, correct? Now there is always a possibility that, you know, maybe the appliance is not working, right? Maybe this appliance is down, right? So in that case, what happens to the traffic, right, which is coming from here? How do you send, where do you send the traffic to, right? So that time what you can do is, ideally, because this is the traffic which is originating from here and destined, it's an internal traffic, right? It's destined to you know, a subnet which is behind this appliance, but this appliance is down, or maybe the transport is down. There could be some various reasons, right, because of which the tunnels are down. So in that case, what do? You have to obviously pass through this traffic, right? When I say pass through, you have to kind of send this traffic you know, on the WAN interface. Now there are many options actually. One popular option is best route, right? You can use the best route on the particular appliance, right? There will be a routing table, and based on the routing table, which is the best route which is matching, you can send the traffic on that WAN interface. Second option is you can pin the traffic on a particular WAN interface. You can say, hey, if this situation occurs, send the traffic on only MPLS. The reason why you can do this is because remember, MPLS is a much more secure secure network than say internet, all right, or the internet transport. So there is an expectation that this MPLS network will be relatively more safer. I mean, though technically it's not completely safe, because, you know, the service provider is there in the middle and they can obviously look through your packets, but compared to internet, it is at least a little less, it is more secure, right? So the idea is that you can, in such scenarios, in this worst case scenarios, you have the option to decide how your traffic needs to be handled, and that is the whole idea of that particular you know, feature, right? Coming back, that's what we have. So you see here, in fact, in this case, you can see there's best route, right? Use the best route as per the routing table, or use, in our case, we'll use MPLS1, right? And the other, I think, rationale here is also that if you think of it, right, your MPLS network is generally fully routed, correct? So you will have connectivity as well, right? So that MPLS network you know, will have connectivity to the destination subnet which you want to reach to, right? So that's the other rationale as well. So yeah, there's just an interesting feature. This is like a more of a, you know, very failover or a very fallback kind of a scenario where you really don't have a edge connect appliance on the other side. Or it could also be during migrations, right? If you're migrating from some other topology to Silver Peak, right, you might have migrated only one side of your network, which is you might have added only one edge connect appliance, and on the other side you don't have anything yet. So in that case, you can use this feature while doing the migration, right? So that until you're able to install the edge connect appliance on the other side, you can start sending the traffic on over your MPLS network. And once the appliance is coming on the other side, the tunnels will be built, and your these particular sections or the IPsec tunnels will take over, right? So yeah, that's another interesting feature as well. The other thing here is maybe this one, right? So you can see you have an option to say when to use the backup, right? Either you can say when your primary is down, then start using backup. In my case, what I'll do is I'll change this to not meeting service levels, which means if these service levels are not met, right, by my primary transports, then I will use the backup. In fact, there is actually another option even to add secondary if you want, right? In my case, we have not added any secondary, but technically you can just go and add secondary this way as well. So yeah, you have again, it's all done sequentially, right? If the primary is not working, secondary will take over. If secondary is not meeting your requirements, then the backup will take over. Okay. So, but yeah, you have an option to change that as well. When do you want to switch? Do you want to switch when it is completely down, or do you want to switch when the SLOs are not met, right? And what does this group 1 represent? This is another interesting thing you need to understand is this is relating to, you see, cross connect. They are mentioning cross connect. So what you can do is you can create a group, right? It can be any group 1, group 2, whatever, and you can attach the same group on the other interface where you want the cross connect to be formed, right? So you can see there is iNet, there is LTE. So between these two guys, there is cross connect. What is cross connect? Something like this, right? Let me say, so this is an appliance, this is an appliance, and on either of the side you have internet, MPLS, LTE, or also internet, MPLS, LTE. Ideally, what you will have is you will have tunnels formed between MPLS, you will have tunnels formed between internet, tunnels formed between, this is default. But if you do something like this, like cross connect, because you see this guy and this guy, iNet 1 and LTE are cross connect, so ideally iNet will try to form tunnels with LTE as well, this way, right? So this is another interesting feature. You can define, because this obviously adds more redundancy, right? Ideally, initially you had just 3 tunnels. Now say you have more than 3 tunnels. So even if maybe this guy is down, right, you'll have 2 more tunnels to reach to the other side via the internet and LTE, right? So that's another interesting feature, which is the cross. Again, not very new. It is there in all other SD-WAN vendors as well, but this is how you do it over here. Alright, so let's move now. All of this is fine. Let's go to the internet side of the house, right? And in the internet side of the house, you can see again you have see iNet 1, iNet 2. I'm going to move the iNet 2 because I don't want it. And you can see primary is iNet and the backup I'm using as LTE over here, right? Because the understanding, this is for internet and cloud services, right? Assuming that your MPLS doesn't have an internet breakout, this would be a typical scenario where you use only the internet, you're not using MPLS, and LTE would be the backup. Okay, here also you can define your thresholds, right? These thresholds are different from what we earlier defined, right? You can change this to 2, this to 100 milliseconds, and jitter maybe I'm not going to configure. So again, when these thresholds are not met, you can see here add backup if no links meet performance thresholds, correct? And you can see here also there is threshold based failover. Use the next preferred policy if no links. So if both of these links are not meeting this one, right, then we are going to use the preferred policy. Here you see this is the preferred policy. You can see the preferred policy is breakout locally, or you can backhaul via the overlay, which means if there is a hub configured, then traffic will be sent to the hub, right, and from there it will break out. So that's the idea behind that. So in fact, if you look at this topology, right, in our topology we have this SP2 which it just has MPLS, doesn't have the internet and LTE, correct? So in that case, technically what is going to happen is this condition is not going to be met. They don't have the internet and LTE, so in that case breakout through locally is not possible. So we are going to be using backhaul via overlay for that particular appliance. So you see how how doing this configuration is really impacting your bio, right? So that's mainly that. And maybe, okay, these are things I did not cover, right? So you have an option to even define topologies, right? You can change the topology. Here we're using a full mesh topology, and below you see link boarding policy. This is interesting again, right? So here we defined what are the links we are going to use, right, for this particular type of traffic, which is real time. But here, this is where you can do the actual, policy of sort, right? So here you can see we are using high availability policy here, which means it is going to use best quality path, right? It will use only one of the tunnel, right? One of the tunnel which is meeting the requirements. But let's say if your requirement is more throughput, right? If compare this with this guy, right? If your requirement is more throughput, maybe for bulk applications, right, you want more throughput, then you can see it is going to do load balancing. So if you have tunnels via MPLS and via internet, they are going to do load balancing. Think of it as a port channel of sort. Traffic will be sent across both the tunnels like this. So that's how you can select different types of, and you can also define custom if you want. But you can see that's the main difference, right? If you want high throughput and high efficiency, they are going to do load balancing. If you want high availability and high quality, they are going to do best quality part, which means only one of the tunnel is going to be used. Okay, perfect. Let me just put this back here. Alright, so now I've done all the settings here for the real-time this thing. I'm gonna hit this OK button. So that's how you can save, right? We can go on to the next guy, which is let's go to the critical apps. Okay, and critical apps, what we can do here is we could even define what a critical app is for us, right? I think I did not talk about that in the real time, but you see there is an option here called overlay ACL, right? So I'm going to hit the pencil icon here, and let's see, these are the applications which have been defined as of now, correct? You can see a bunch of applications here: WebEx, Salesforce, and Slack, Workday, right? So, and you can add obviously an application. I'm going to say, let's see, yeah, so I think I'll add an application. I'm going to say add a rule, right? And that rule get added here. I'm going to click on this match everything pencil icon, right? And here you can see there is there's something called as more options. I'm going to click on that guy. So you have again options to select, like if you want a particular application, you can click and you can start writing the application like TFTP or something like that, right? You can add a particular application if you need. What I'll do is, I think I mainly want to look at the SIPs traffic. If I'm not wrong, that is I can use port number for it, right? And the port number probably is 445, right? So I'm going to define a particular application with that, right? So I'm going to hit the save button over here. Okay, so you see port 45 is showing up here, right? So I'm going to save it over here in the associate. I'm going to hit the save over here as well. Okay, so this is mainly for the SMB, right? Samba protocol, SIPs protocol. That's the port number, so I'm going to use that, right? So there you go. So we have basically created one more type of rule here, which is 445, right? Now all the traffic for 445 will be kind of matched with the critical traffic. Okay, and what else do we have here? So you see the boost part, we did not talk about that, right? You can enable the boost at a overlay level. I'm going to enable it for this guy, right? There you go. I've enabled the boost. And remember, we have configured the boost at the device level, right, on the deployment profile, like how much amount of boost, but you have to then enable it at the particular bio, right? For that application, do you want boost or not, right? So that we can use the boost for the traffic which is flowing through it. Okay, so that's the other piece, right? I'm going to probably, there's nothing much to be done here. Rest all is fine. MPLS internet is selected. This one I will go back to maybe saying if they're not meeting the criteria, then use this, right? I will not define any anything over here. That's fine, because I've already showed you how to do it. Clearly see here the link boarding policy has changed to high quality for this one, right? Here also, let's remove this. We don't want this guy. Rest all looks fine. I'm going to hit the OK button. So that's about the critical apps, right? I mean, once you figure out for one of the bio, right, the rest everything is pretty straightforward. So we can click on bulk apps now, right? And we can do similar steps here as well. One sec. or just to remain consistent, let's actually do it, right? So that let's actually go back to the critical apps, right? And let's make sure that all the settings are very similar to the real time. When I say real time, some of the baseline settings, right? Like this one, let's change this to 2 and maybe 100 milliseconds, right? Peer available option, let's change this to use MPLS1. Okay, so that's pretty straightforward, right? What else did we do? I think we went on to the breakout section, and here also we added the values earlier. Let's do that. And we have removed that's fine. And let's also enable this. Okay, so I think that takes care of things. Okay, so that's fine. Similarly, let's for the bulk apps, right? Even for the bulk apps, let's do okay, so you see there are quite a lot of these things. Let's remove the MPLS2, INET2. Let's just keep these two guys. Let's change this to not meeting SLAs. Let's change this to 2 and 100, right? Change the peer unavailable to MPLS1. Perfect. So this is fine. And whereas on this guy we might have to again change this to 2 and 100. Okay, let's remove this guy. So that's mainly it. Now coming to the internal subnets, do we want any other things to be done here? Okay, for this one, let's also explore how do we change the topology, right? So here you see there is a topology called mesh. We will change it to hub and spoke for this one, right? Which means, remember, keep a mental note. We also need to create a hub later, which we will do. But for now, let's just change the topology over here. So you understand the hub and spoke topology, right? Pretty straightforward. It is like the traffic will be sent to a centralized hub, right? Whereas mesh is nothing but you have assumption is that every edge connect appliance is able to reach the other appliance directly over IPsec tunnel. Whereas here what will happen is the traffic will be first tunneled to a hub, and from the hub the traffic will be sent to the destination hub. So yeah, the good thing about all of this is how the routing is happening under the hood. So all of that is kind of you don't have to worry about it, right? All the related route policies and all of that is going to be taken care by Silver Peak, right? All you have to define is per application how do you want it to be handled, right? And internally things are going to work for you. Okay, so yeah, that's pretty straightforward here. What else? So all of this looks good. Coming to this guy, this is also fine. So I'm going to hit the OK button. Similar, let's come to the last one, which is the default. So if the bulk applications, right? By the way, we probably did not see what bulk applications are. Let's click on once again the bulk apps. We can actually look at the match ACL, right? And we can actually click here, and you can see if you put on this guy, right? You can click on the pencil icon. You can see these are the various applications considered as bulk apps. You can obviously add more, but you can see it's SFTP, GitHub, Dropbox, and all of that is considered as bulk apps by default. Perfect. So I'm gonna cancel that and go back to the default overlay. All the traffic which doesn't match any of the above three, right, will obviously match the last guy, which is, I think, maybe things like if you don't have any specific rules for ping and telnet and all of that, right? So all of that might match here. Okay. All right. So here also let's do the minimal stuff. Let's remove the let's probably change the order here as well, right? So we gonna use what we'll do. So here we will change this to 2% and 100 milliseconds, and all of this is fine. MPLS INET2. Okay, so this is good. We can change the peer unavailable option to MPLS1, correct? So this is good. What else? Let's go back here. Let's remove this guy, change this also to the similar values which we had earlier. Okay, all right. So anything else we want to do here? I think that's pretty straightforward, right? So we can also enable maybe boost over here, right? The boost is enabled, correct? That's good. Looks all good. I think we are good to kind of deploy, correct? Let me check. All right, so that's predominantly that, right? So what we can do now is, once we have saved the changes which we have done, here you can see it clearly shows in the boxes what are the changes which we have done, right? So that's pretty cool as well. What's this plus button? Okay, so you can see excuse me, more details here as well. What we have done is remember the boost part, we have enabled boost as well for all these three overlays, whereas for the first one we have not enabled because boost really doesn't make sense for real-time traffic, right? That's the general understanding. But yeah, so these are all the changes, right? Now we want to deploy these changes. All you have to do is save and apply to overlays. Remember, all the overlays are present on all the 5 appliances, but we don't have hubs yet. Make sure this overlay has appliance. Okay, that's fine, but we can still hit the save button here. And once you do that on the top, the configuration will start getting pushed. You can see over here the configuration is getting to be pushed. So let's wait for probably that to be done. And with that, the configuration has gone in, right? Remember, we still have one more step to be done, which is configuring one of the appliances as the hub, right? Because we used hub and spoke topology over here, correct? For bulk apps. Which one do we select? Let's look at our topology. Let's probably select SP1 as our hub because it has connectivity to all the 3 transports, right? So let's probably pick that guy as our hub, which is going to be ECBV1, right? So so especially for ECV2, right, which doesn't have all the transports, it will be able to backhaul the traffic to the SP1, right, the Silver Peak 1, my bad. Okay, so how do we do that? All we have to do is probably go to configuration, right, overlays, and you will find a section called hubs over here. Okay, so there you go. Okay, so here you can see we can select a particular appliance as hub. Okay, and you have an option to create as a stub hub, but I think I'll just use a re-advertise routes, and I'm gonna hit the add hub button. Confirm. Right, so you can see some configurations is going through now. Click on this guy, the top here. There you go. So maybe let's remove the search. Okay, there you go. Some configuration is happening, correct? Because we have now selected our SP1 as the hub. And let's wait for this to finish. All right, so the orchestration is finished. I'm going to close this one, and maybe we can just refresh this guy. And there you go. You can see SP1 is appearing as hub, and you can see it's a hub for these many overlays, correct? Which is real-time, critical, bulk apps, and default overlay, right? Which is pretty cool, right? So that's another thing, right? When you create a hub, it becomes, it is going to be an hub for all the overlays, but at the same time, in these overlays, right, real-time, critical apps, and even the default overlay, we have not configured the hub and spoke as a topology. So in that case, the SP1 will not be used as the hub, but when you create a hub, it's generally gonna act as a hub for all overlays, right? But in our specific scenario, we have used only bulk apps to use the hub, so only that guy will be sending the traffic to the hub, and from hub it will be sending all the way to the other spokes. Okay, I think there is an option to even go to maybe monitoring and look at the topology here, and we should probably see, let's see if this loads. Sometimes it doesn't. Okay, there you go. So we have so you can see this is probably showing. Let's zoom maybe out, I guess. Sorry, let's zoom in, because this is showing the world map. Remember, our devices are in London, and there you go. So this is where our devices are, right? So now if I probably try to zoom in a little bit, there you go. So this is how it shows. This is basically for all overlays. What I'll do is I will change this to, let's look at only real time, right? So real time, okay, did it change? Maybe not. Let's change to bulk apps. Okay, for bulk apps you see, okay, so for, let's compare, right? If you go to real time, you can see it's full mesh. So you can see all the 3 guys are connected, right? So this 2 is representing nothing but there are 2 appliances at this site. That's the meaning of it. Okay, so that being said, okay, so the zooming part is not that great on here, right? So let's see. Okay, that just went full screen, my bad, but you get the picture, right? When we selected bulk apps, you see this particular line went away, right, from this guy, because it's a let's see if I can zoom in a little bit. Yeah, there you go, right? So because I selected bulk apps, and London is acting as a hub for me, you can see traffic is going to go from here to the hub and then to the other appliance. Okay, that's a great way to check if for your particular overlay, do you have a correct topology. Alright, so let's now try to do some pings, right? To look at the flows if certain things are working fine, correct? So first thing is, let's actually go to our topology here, and remember we have a Berlin PC. So we'll go on to this Berlin PC and try to ping this internet host, right? Which is 11.1.111. Ideally, what should happen? Ideally, we should have, I've forgotten which is the primary, secondary here. I think it is maybe SP4 is the primary as per the VRRP. But yeah, one of the appliance will pick up the traffic, and then because this traffic is not internal traffic, it is internet or cloud based traffic, right? So it will use pass through, correct? And if I'm not wrong, I've made sure I'm using internet as my pass through, right? I've made internet as the primary and LTE as the secondary. So I think that is going to happen. So the traffic will be sent via pass through via the internet transport, right? So let's check if that is going to happen. So I'm going to go on to the Berlin PC. So this is the Berlin PC, right? I've opened it, and I'm going to ping 11.1.111. Let's maybe send a little more number of pings, maybe like 10,000 pings. Okay. So while that is happening, what I can do is I can go to monitoring. Under bandwidth, you'll find a section called flows, active and recent flows. Click on that. And once that happens, right, you can actually look at the flow. So what I'm going to do here is I'm going to do 11.1.1.11, right, and then we'll hit the apply button, and there you go. So we have so this one, right, the first two flows. In fact, let's select only the active ones. Sorry, I selected this. So let's select only the active ones and hit the apply. There you go, right? So we got only the active flows now, which is going through, and we can click on this detail button, and you can see the information over here, right? You can see which overlay it is matching. The default overlay it is matching, because why? It is a ping traffic, ICMP traffic, right? So it is matching the default overlay as a default bio, right? And which overlay it is actually using, which IPsec tunnels. You can see it is using pass through. It's not using IPsec. It is using the pass through. It is using the INET one, right? So that's what it is using, and you can see information read routing, right? It shows that I'm using 108.1 as the next hop, which is which one? If you look at my topology from SP4, 108.1 is this guy, right? Which is the INET, which is perfect. Okay, so that's the expected value, and it is using that one, right? You can see the this thing. What is that? I think what else should we look at here? Yeah, I think that's predominantly yeah, you can see the TX reason why, which one. You can see the primary. It's not using the backup, it is using the primary, because the INET interface is up and running, right? So that's one way to kind of verify. You can go to this flows tab, and you can put whatever IP you want. You can send some traffic, and you can kind of look at the traffic which is which is active, right? The active flows from each of your plans. You can look up here and see, is it really following the right policy which you have configured. Alright, so the next one is we'll try to use the SIFs traffic, right? So remember we created port 445, right? We kind of created port 445 to match the critical traffic. So we'll try to check if that is going to work. So what's our game plan here? We'll use so we'll use the Paris PC, right? And we'll use the internet host, and we'll try to basically send some SIF traffic, right? 445 traffic we'll send from this particular client. Ideally, what should happen? I think out of SP2 and SP3, this guy is mostly the master, right? Or VRRP master. So traffic should hit this guy. And again, this is pass-through traffic. Now, pass-through traffic ideally should use internet, right? But this guy is not connected to internet, correct? You might ask, this is connected only to MPLS, but remember we have also configured the sharing option, right? Edge connect high availability. So this guy is ideally getting the internet and 4G through this guy, correct? Through some virtual tunnel. So remember we have set that up. So ideally it should go like this. Traffic should go like this. It should go like this. So this is my expectation, right? In this way, this is the path traffic should follow. So let's see if this is really going to work as per our policy, right? So let's go back. Let's go to Paris PC, right? And on the Paris PC, what we'll do is we'll probably come here and we'll select the 11.1.11, right? So this is the internet PC, right? And what I'll also do here is, let's actually go here to monitoring bandwidth, and let's go to the active flows. All right, so that's fine. I've put 11.1.11. So what I'm going to do now is I'll just come to the users, right? And let's go um, and I think in the downloads folder there will be some folder here, right? So I'm gonna just copy this one, right? Come back here, come back to 11 dot. So I'm using shifts, right? So I'm basically inside the 11.1 11.1.1 PC, right? Inside that, maybe let me go into, I don't know, maybe like desktop, right? And I'm gonna paste this particular file, right? I'm gonna say copy and replace. That's fine. So there's already a file with that name. Okay, so this is going through. Is it really going through? Let's have a look here. Okay, so I think it is going through. It's copying, right? You can see there. Okay, there you go. It's copying. So I can quickly come here and refresh this guy or apply this guy. Maybe there is a IP address for sure. Please enter IP subnet. Okay, there was a issue here. So let's hit the apply. And there you go. We have 10.99.20.11. That's the Paris. You can see IP address. You can see shifts traffic. It's even able to figure that out, right? And you can see in the port here it is 445. Okay, and let's look at the details for this particular flow. You can see as per our expectation it is using pass-through INET, though it doesn't have a internet transport. It is using the transport from the sharing, right? You can see that here in the WAN routing. You can see this gibberish kind of an IP address 169.254. Remember when we did edge connect high availability, these were the IP addresses we saw, right? So 169 subnet. So it's clearly using the INET from the SP3. Okay, and it is correctly getting categorized as critical apps. The traffic is going via pass-through INET expected, right? So that kind of confirms that what we are doing is working, right? Whatever policies we have put in is working. All right, maybe one last thing which we can have a look here before we wind this session is, if you go back here, right? Let me close the flows part. In the monitoring, there are many other cool features which might be of interest to you, right? For example, if you go to monitoring, right, we looked at topology, alarms and all we have already checked out before. There's also reporting, which you can create some reports, but maybe the other interesting things are things around trending, right? So even if you probably put trends here, you're going to get quite a lot of trends, right? So for example, let's maybe look at I think there should be something called tunnel trends, right? I think this one, or maybe let's just go from here, right? Monitoring, tunnel and trends, right? So here you can select a couple of appliances and it will show you like what kind of on the various you can see here, these are the various overlays, right? So for default traffic, for real time, for critical, for bulk app, so each of them it is kind of showing you. Remember we sent some traffic earlier, so that's why I believe it is showing this one a peak over here, right? And then it has gone down. So you can see some trends on your WAN transfer, not only WAN, right? You can see it on the LAN as well, and also gives you a ratio, right? So that's pretty cool, right? So all the trending part. Then I mean, you can similarly see trends for all the other parameters as well, like DSCP, QoS and all of that. There's also a very interesting live view, right? So live view is, it just gives you the live view. Like for example here, from SP1 going to SP2, there are various tunnels, right? So these are the various overlays, and for each of the overlays you have various tunnels, and you can clearly see here that you can probably click on one of this guy, right? You can click on one of the live view and it will start giving you the live view, right? It will tell you if there are some tunnels. You can see from SP1 going to SP2 you have, for bulk apps, right, you've got this is like the overall health of sort, whereas here you can see INET to INET, MPLS to MPLS and LT to LT, right? So for all of that you're getting up and green in color, which means all the three tunnels are meeting what, the SLOs, right? If one of these tunnels has some loss latency, then it will start showing us that not meeting, or if it is down it will show you the colors, right? So these are all like very useful tools for your troubleshooting purpose. All right, so with that I think we can close out the whole session on business intent overlays, right? Just to recap, what we did was we spent the first few minutes understanding everything we needed to know about business intent overlays, correct? We kind of spent few minutes there, and then after that what we did was we started configuring various business intent overlays. By default you get these 4, right? You can create more as well, and you'll get some settings by default, but you can tinker them based on your necessity, right? You can change the topologies, change the interfaces, the transports which will be used, right? You can give primary backups, right? You can define that preference on the and then you can also enable boost, right? And few other settings. Whereas on the internet side as well, you can select you want to do local breakout or you want to backhaul traffic, things like that, and you can again select the backup interfaces over there, right? So we did a bit of settings here, and then just to verify, we sent some flows, right? We looked at how we can use monitoring for that, right? You can go to monitoring, you can go to bandwidth, and then you can look at active flows here, right? So as you're sending the traffic, you can look at what's really happening. Further, you can actually use some other monitoring tools like tunnels, trends, and you can use the live view, right, to kind of understand how the tunnels are really performing, right? You can actually further drill down and look at the underlay and stuff like that, right? So I would suggest you to kind of check that out. There is so many features here, would take me a lot of time to go through each of them, so would suggest you to kind of check it out. Silver Peak really makes it pretty simple to kind of use most of these, right? You just need to click and select and fiddle with it, and you'll be able to figure things out. It's that simple. You don't really need a lot of configurations and all of that to kind of get started, right? So with that, we kind of wind up this particular video on BIOS, and hope we are going to come back with a few more videos on the Silver Peak in future. Okay, cool. Thanks a lot for watching, guys. Have a good one. Bye.